In this video, we will be reviewing for our semester exam. We'll be looking at the side that says 6A. Number 1, the probability of an outcome of a random phenomenon is D, the proportion of a very long series of repetitions. This is our definition of probability in the long run. All right. In the long run. Think about the law of large numbers, which we did our last project on. Alright, that is essentially how we view probability. It's the frequentist definition. Frequentist definition. Frequentist probability. Number 2, which of the following represents a legitimate assignment of probabilities for the sample space? Well, the sample space contains yes, no, and maybe. The key here, what they're driving at, is the sum of all of the events must add up to 1, and that's A here. 0.4 plus 0.4 plus 0.2, that does indeed sum to 1. The probability of the sample space must equal 1. The sum of all of the events. Number 3, what is the probability that we choose not a heart? Well, our complement rule, if the probability of some event A is equal to 1/3, the probability of A complement, we also will use the notation A prime not A, it is 1 minus that. In this case, 2/3. If some event has a 1/3 chance of happening, as a 2/3 event of not happening. Well, we want not a heart. Well, the probability of a heart is 1 in 4. 1 in 4 of the cards are hearts, so the probability of the complement of that, not a heart, is 3 out of 4. And 3 out of 4 is C, 0.75. Alright, number 4. The probability that you win the next 2 matches. You play regularly against your friend. From past experience, you believe the outcome is independent. Well, independent means knowing one doesn't give you some information on the other one. You beat your friend this time, next time it's still 60%. Maybe that's true, maybe that's false, but that's what you're assuming. We had 2 probability rules. They were really 1 rule. The first rule says the probability of A and B, A intersect B, is equal to the probability of A times the probability of B. This was if they were independent. If independent. And that's what we're saying here. Now our general probability rule was this. Probability of A and B is equal to the probability of A times the probability of B given A has occurred. This is the general rule. It works all the time. General multiply. Notice they both involve multiplication. And if events A and B are independent, then this is equal to the probability of B, and it becomes this top rule. So this rule here is simply a special case of this rule. Well, it tells us that our 2 events are independent, so we just multiply. In this case, it's simply 0.6 squared. 0.6 times 0.6, that is 0.36. The probability that you win twice is simply 0.6 times 0.6. Win and win. Alright, number 5. Again, we're assuming A and B are independent. They want to know A or B. Well, since A and B is independent, it's okay to multiply them together. The probability of A and B, again, that's the intersection. We say probability of A and B. Since they're independent, we can multiply the probability of A times the probability of B. In this case, that is 0.24 times 0.52. Well, that is equal to 0.1248. That's A and B. We're seeking A or B. Well, the probability of A or B, notationally, we say probability of A union B, that is equal to the probability of A plus the probability of B minus any overlap. That's the A and B. We could draw our Venn diagram for this situation, but we have all of our factors. We have A, we have B, and we just calculated that overlap. So this will be 0.24. Probability of A is 0.24 plus the probability of B, 0.52, minus the overlap that we just calculated, the AND, 0.1248, and I believe this will be C. Right. Number 4, which pairs of events are disjoint, mutually exclusive? Disjoint means they're not joined. If you have event A here, and you have event B, they are not joint. This is disjoint. One thing that you need to know is if you are disjoint, you are not independent, because here, if I know that A has occurred, B is guaranteed to not occur. Disjoint events are not independent. And that's kind of contrary to what you think of as independent. You think, hey, independent, they're standing alone. Yeah, there is the definition of that in the English language, but for us in probability, that's not the definition. Independent means knowing that one outcome occurred gives you no information about the other one. Well, that's certainly the case for disjoint events. If you know A's occurred, B cannot occur. Disjoint means no overlap. Not joined. Alright, so in this case, the two that are not joined are D. The numbers above 100 and the numbers less than negative 200. There is no such number that falls in both of those sets. 3. Can you conclude that we can multiply in this case? Well, we can multiply when the events are independent. Alright. Government data shows 26% of civilian labor force has at least 4 years of college, and 15% work as laborers or operators of machines or vehicles. It's unlikely that these events are independent. If you have a college degree, you're probably a little less likely to be a laborer or operate a machine or a vehicle as a part of your job. So no, it would be inappropriate to multiply these two together, because these events are almost certainly not independent. Number 4, if a peanut M&M is chosen at random, the chances of it being a particular color are shown in the table below. Well, we know all these probabilities must add to 1. 0.3 plus 0.2 is 0.5, plus 0.2 is 0.7, 0.9, that's 1. These all sum to 1, thus blue is 0. No chance of getting a blue. The probability of randomly drawing a blue M&M is, according to distribution, is impossible. E. Alright, that concludes this video.